Hello and welcome to another Java tutorial. In this tutorial, we're going to continue on our journey on learning Java by doing different projects. And the second project, I thought it's a good idea to have a quick look at Maven and also have a quick practice on Java Swing API, which allows us to create graphical user interfaces. So what is Maven and what do we want to do with it? So if you have used Maven before, you know that Maven has some central repositories, right? Like Maven Central, and people can release their jar files to there, and other people can download them, use them in their projects. And sometimes you find a jar file which you want to include in your project, but you cannot find it on a Maven repository, so you kind of need to tell Maven to use this jar file, but it doesn't have to go and download it. It's already available on your computer. In order to do that, you want to basically install that jar file into your local Maven repository first, and then Maven can grab it from the local repository, right? So you cannot point Maven to any jar file anywhere on your system. It has to be previously installed into your local Maven repository. And Maven command line tool can do that, but you have to configure it. And we want to eventually create a simple graphical interface which allows user to specify the path to a jar file, and then specify the group ID, artifact of the ID, and the version of the jar, and you hit install, and it just goes ahead and uses Maven to install your jar file into your local Maven repository, and then it shows the output of the Maven and all the log info on the window as well. So it's a very simple project, but it's good to have it because sometimes you definitely need to download a jar file which you cannot find it on any Maven repository, and it's good to know how to quickly install it and use it. So Maven command line argument. So Maven is a command line tool. So if I open my terminal, let me close this and go back to here, and then let's open a new terminal. And I have already installed Maven. I'm on macOS. I'm using Homebrew to manage my packages. So if I say mvn, if I first check if I can find mvn on my command line, it's available on my command line. It's in user local bin mvn, and this is a symbolic link. The actual installation was done by Homebrew. And if I say mvn -- version, it tells me exactly where the Maven home is. So it's using Homebrew. It's in the Maven folder 3.81. So I'm using Maven 3.81. And then if it can find Java on the path environment variable, it can also tell me which Java it can find. And right now it finds Java JDK 15, which is correct, because if I look at what is my Java home, it's set to the JDK 15. So Maven by default looks for Java home environment variable if you have already defined it. So Maven uses the JDK that you have defined for this Java home. If Maven cannot find Java home environment variable, if you haven't defined it, then Maven tries to see which Java is basically available on your path, and then whatever Java it finds, it uses it, right? So the default is Java home. If it cannot find Java home, then it defaults to whatever Java you have. So Maven is a build tool, which means Maven doesn't have any Java C or Java compiler. So basically you tell it where my JDK is, and then Maven knows how to use the tools inside your JDK to build your application. Okay. So add mvn executed to your path environment variable so you can access it. Define Maven home. This is not necessary, but it's good to also define a Maven home as an environment variable. You can check the version that you have installed, the Maven version, using -- version flag. And Maven uses whatever Java JDK that is on the path environment variable, right? So as I said, by default, Maven looks for Java home. So the default is Java home. Default is basically Java home, and if it cannot find Java home, it searches your path and see if it can find any Java on your path, any Java compiler on your path. If yes, and then it basically tries to use that Java compiler for your build. Okay. And here I have an example, mvn hyphen version. First you can execute this to first make sure that you have mvn installed and it's available on your path. And then the second one is it tells you which jdk it finds. All right. And then you can also look at the Maven command line options using hyphen help, and I have listed them here, so at some point we probably look at them. There's a lot of things, and if you're using Maven with an IDE already hides a lot of these command lines, right? You don't need to worry about configuring Maven. So if you really want to build your Java project using the command line itself, then you have to be aware of some of these flags, right? But most likely you're using an IDE and you don't really care about that much about the actual command line arguments, right? So what do we care about? We care about having a Maven and having a jar file, which we have downloaded, and tell Maven to install it in the local Maven repository so that I can use it. And by default, the local Maven repository is called .m2. It's a folder on your somewhere on your home directory. .m2, that's the local Maven repository, into .m2 local Maven repository, right? And there are two ways to do this. One is using the Maven install plugin, right? You tell it mvn invoke the install plugin, and each plugin has some goals, right? And the goal is install a file. So we tell the install plugin, hey, I have a file, just install it. And what the install does, it takes your file and install it into your local Maven repository. So that's one way. And the other way, so the way we specify this, so install file. So we're using install plugin, and then we're using install file goal, right? So install is the plugin, install file is the goal. And then but as you see here, I take this from Maven website. It says that this plugin and this goal is primarily used for installing artifacts which were not built by Maven. So if you so when you build your jar file with Maven, there is a POM file or project object file inside your jar file, and it has all the information that Maven needs, right? The group ID, artifact ID, etc. So if you have a jar file that doesn't have a POM inside of it, you can you basically need to use this mvn install file, right? And then the command is mvn install plugin install file go, and then you specify Java basically system arguments, which Maven also knows. So all the system arguments start with -d, and Java knows how to tokenize these, and then system arguments are -d key equals value, and JVM or Java knows how to tokenize this, right? So -d, first you have to specify your file. File equals your artifact.jar. So whatever the absolute path to your jar file. So I'm going to say that this is the absolute path to your jar file, right? Absolute path to your jar file. And then POM file. So if you're using a jar that doesn't have POM, you ignore this, and all these arguments that are inside the square brackets, these are optional arguments. So all of these are optional arguments, right? A square brackets means optional argument. Optional, these are options or optional arguments that you can pass. -d source. So if you have also the source file of your jar file and you have it as a package jar, you can specify that java group ID, artifact ID, and version. These three are the most important one. And obviously we're assuming that we're installing a jar packaging, so something that is a jar. And then you can ask it, if you don't have the POM, you can ask it to -d generate POM true, and that's by default, because Maven, when install it in your local repository, there has to be a POM file there, so that later if you want to use that jar from your local Maven repository, Maven goes and reads the POM file and knows which jar you're talking about, right? So the coordinates for finding a jar in the Maven local repository is group ID, artifact ID, and version. And no two jar files can have the same group ID, artifact ID, and version. That's how Maven differentiate the jar files in your local repository, right? So these 3 coordinates has to be different. At least one of them has to be different for any jar file to be uniquely identified. And then so this is how we can use this. And then the other basically the other approach is if we have a jar file that has been built by Maven, right? And which means it has a POM inside of it, right? And then if the jar has a POM file inside of it, you can tell Maven to use it. And so what you can do, you can specify the full path of the Maven plugin. So mvn or mvn, what is the plugin? It's Maven install plugin. So org.apache Maven plugins. From all the plugins, select the Maven install plugin. What's the version? 3.0.0. And then in a style file, again, we're using the install with install -d file. And so if we don't specify, so when you say -d file, and then basically it generates the POM file, and it assumes that, or first it tries to look inside your basically so if you point it to a custom POM file, it's going to use it, right? So this -d POM file is a is basically what you specify. You tell it use this POM file with this jar when you install it. So Apache Maven install plugin can include a pre-built custom POM with the artifact in the local repository. Just set the value of POM file, which is a system property. So -d POM file equals something, parameter to the path of the custom POM, right? And but as you can see here, again, for the install file goal of the install plugin, -d generate POM is by default true, which means if you don't give it, if you specify group ID, artifact ID, and version, Maven already creates a POM file, puts it in your Maven local repository along with the jar file. And then when you want to use that jar in your other Maven project, you have to specify that group ID, artifact ID, and version, right? So this is the most straightforward thing. Now, after understanding this, then next step is to quickly build a graphical user interface that interacts with the operating system command line to invoke the Maven command line tool. And then again, you try to use the Maven install plugin and install file goal. And this is what we start doing in the next lecture. So please stay tuned, and I'll see you in the next one. Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on building a simple graphical interface for installing the jar files into our local Maven repository. We're going to use the Swing API, and you probably are also aware of the JavaFX, which is a more modern version of the graphical interface that Java provides. But Swing is by default included in the JDK. And that's easier to use, then we just can quickly use it, and it looks relatively nice. I mean, it doesn't look terrible. And then I'm going to use a graphical interface to build the GUI, and that's called WindowBuilder plugin for Eclipse. If you're using other IDEs, or you like NetBeans or IntelliJ IDEA, they also have their own plugins for allowing you to drag and drop GUI components, right? So it makes life easy. And what do we want? We want to have a window, and obviously this is a JFrame. So I'm going to also, so the top level window is called a JFrame, right? JFrame. And for each, and then inside there we can have separate sections, and each section is called a panel. So we have a J panel, and inside each panel we can have different control components. So menu bar is separate. So menu bar is just associated with the JFrame or window itself. So we add a JMenu file like settings. These are JMenu, and each menu can have separate items or multiple items, and each item is called JMenu item. For example, in the file, we want to have a menu item to quit the application altogether, which quits also the JVM that is running this. And then here we want to tell user some information. So we put labels to display some text. So JLabel is what we use. And then we have JText field. These are where the user actually puts, we can grab the input from the user using JText field. The user can type here. We have JButtons. So these are buttons and they have actions or events associated with them. So for example, when a mouse enters the area of the button, what happens? When a mouse clicks the button, what happens? And you can have multiple buttons in a JPanel or a JFrame, that's fine. And then JCheckbox, this basically returns a boolean, right? If you want to check if something is true or false, you can use the JCheckbox, and it tells you, for example, if it's clicked or not. So if you need to make a decision based on some parameter to being true or false, you can use a JCheckbox and check if it's selected or not selected, right? And then I have also this button install, which does the last thing and invokes Maven and basically installs the jar file that user provides based on the group ID, artifact ID, and version, and installs it into the local Maven repository. All right, so let's head to Eclipse and start building this nice GUI. So in Eclipse, I'm going to create a new Maven project. I mean, you can also build it without Maven, but I'll try to build it with Maven. And then it's a simple project, and then a group ID, let's call this basically com.learn Java, and then artifact ID Maven jar installer, and version I'm going to set it 1.0, and then let's finish this. And you're already familiar what happens in Eclipse. It sets the default JRE to 1.5 despite the fact that I have JDK 15. So we just quickly go to the POM file and tell it to use the JDK in the properties, use the JDK 15 as the compilation and also execution. So Maven dot basically compiler.source 15 and maven.compiler.target 15. So let's save this and then right click and then go to the Maven and update project, and hopefully this sets our JDK level and JRE execution level both at 15, right? All right, so so we have this POM file, and right now it has our two properties. And again, each POM file, each Maven project, or basically each POM file is uniquely identified by the group ID, artifact ID, and version. And when you create the artifact of your project, which is a jar file, for example, it has this unique identifier, group ID, artifact ID, and version, right? These are the unique identifiers of your artifact. So what do we want to do? I am going to basically let's see. So let's go to file, or maybe right click here, new other, right, in the source main Java, and I have already installed the WindowBuilder. So I'm going to say swing designer, and I want to create a JFrame. Name in the package, let's call this Maven underscore installer, and then in name is we can say, so we should have two classes. One is the GUI, and then the other one is the main class that has a main method and invokes the graphical interface. So let's call it jar installer GUI. And right now it's trying to create that class jar file, and also it's going to open up the WindowBuilder GUI, which has the graphical interface for basically creating the drag and drop. And so I'm going to save this Maven jar. So far I have already configured my my WindowBuilder to, when it opens the GUI, it also puts the source code on the left side. So if I go to Eclipse preferences and go to let's see, WindowBuilder, and there is a delay between updating the GUI and updating the code. I typically prefer this delay to be large, like 5 seconds. Otherwise, it just, as soon as you change something, it just goes and tries to refresh the code, which is annoying at some point. So you can change the editor layout. Right now I've selected side by side with a split pane, source first, which means put the interface of the window builder and also the code side by side, and the editor first, which means put the source on the left side. And I find it very useful, and it makes life easier. You just change something, for example, especially when we get to the events, you add some event to the button and it automatically adds the code, and you go and implement it, right? And then in the window builder, what I want to do in the swing, in the code generation, there are a few things that I typically like to change. And first of all, variable generation. So if I add a component like a J button, right, I don't want them to be local. I want them to be as a private fields, right? And then you see, if you select the as a field, then what happens, it defines them global. Then I can use these global variables, and Eclipse automatically adds the initialization method in the constructor, so it initializes this button. But then the good news is that because these are global, or basically a field, not a local variable in the constructor, you can use this in the methods that you define for handling the events or actions for the buttons, right? Which is nicer in my opinion. So variable generation, statement generation, method name for new statements. We can say init GUI. So in the constructor is it just calls this init GUI, and then let's see. It also looks nicer probably to have these blocks, or maybe we can just select it as a flat. Component creation code. Let's see what happens. Prefix component, it's let's keep it like this. And then event handlers, I don't want to create init class, create anonymous class, implement listener interface, create a stub event handler. So right now you cannot, I guess, configure it to use lambda expression, so it goes for the anonymous classes. You can also define inner class, or you can ask it to basically ask your JFrame class, the top level class, to implement some interface. For example, for buttons, it means action listener, for example, or event listener, something like that. So mouse listener, for example. Create a stub event handler method name. So component name, event name. Instead of do, I'm going to say maybe just add performed, something like that. Okay, so let's apply and close. All right, so we have a main method. It has already created a main method for us, and then jar installer GUI. What we can do right now, we already created this, so we can maybe delete this and create a new one. So new other JFrame, and let's say jar installer GUI. Let's finish this, and then and now we have jar installer GUI. Okay, and then right now we have this JPanel. So at the top level, or basically JFrame, at the top level we have the window JFrame, and it has one content pane inside of it, and you can see the borders of each component. So JFrame, content pane. And right now all these content panes, they're global. As we discussed, these are fields. And to show you the implementation of the action, so if I add a button here, it's a big button, and if I tell it add event handler action performs, this is when the This is when somebody presses this button. Right now, it implements as an anonymous class. Action listener is the interface, and it's implemented as an anonymous class. We can always implement it as a Lambda expression, but then we ask it to separate the implementation in another method, which takes the action event, and the name right now is button action perf. Okay, so the naming is not that good, so we can go back and change the naming. So component name and then event name, for example. So button action performed, that's fine. Yeah, all right, that's fine. So we can delete this button, and I believe it's going to also remove all the methods. And right now, as you can see in the constructor, we have this init GUI, and that's where all the stuff are initialized. And all right, so let's start by implementing our interface, and we already have an idea of what the interface is going to look like. So the very first thing is JMenu. So in the components, in the menus here, we look for the JMenu bar. That's the top level thing. And then we have one menu bar, right? Menu bar, new JMenu bar, set JMenu bar. So each JFrame can have a menu bar. Remember, we are extending JFrame, so we can call the methods in JFrame, right? And then a menu bar can have menus. So JMenu, we're going to add a menu, and then we're going to call it file, for example, right? And then let's save this. And we can always run it and look at the implementation, or we can run the Java class because it already has a main method. The best practice is to have this main method in another class, but right now we can also run this directly. And let's wait this to build, and it's going to run our Java application, and we have our window, and this is the file. So we have JMenu and then JMenu item. So each menu can have menu items. Let's call this quit. All right. And then so what happens when this quit is pressed? So we right click, we want to add an action or event handler. In the event handler, we have action. Action means when the mouse is clicked. So action performed. And here we have, maybe before that, let's change the name. So quit. And it's going to probably, let's save this. JMenu item quit, and JMenu properties. Let's see. I want to see if it changed. So add event handler action performed. We can, I want to rename it, so let's save this. So let's run this again. Add event handler action performed, and now it says quit action performed. And we can also capitalize this, but that's fine. So quit button action performed. And what do we want to do? We want to just say system.exit with a status of 0, which means we are doing okay. We can also look at the status, abort, error, although these are for JFrame actually. So a status, exit a status 0, which means the application terminated correctly. So normal application termination. Right? And we can also print something to the console, quitting application with 3 dots. So if you run this, hopefully this is going to work fine. And again, I want you to understand that if you don't have any experience with Swing, first of all, you see how easy it is having a graphical interface to drag and drop components. And in the code, if the code and GUI are side by side, it's very easy to add action handlers, which means what happens when we click on this. And right now it doesn't implement as a Lambda expression, but we can do that too. So quit, and it prints quitting application, and it closes the JVM and the terminal. So this works fine. And again, this is the concept of event handling. For pressing something, it means an action performed usually. And I can also convert this into a Lambda expression, and the way this works is that we pass the event and then we tell it, so instead of all this business, we're going to say that quit dot add action listener event. It passes an event to the function, and then quit action performed. So this is a Lambda expression implementation, which is much nicer, right? All right, so let's make sure that everything works fine. Again, file, quit, yeah. All right, so, and then the other thing is for the JFrame, the top frame, we can look at its properties. So it's a class JFrame, always on top. It's false, which means other windows can come on top. Auto request focus, which means when you open it, the focus is on the default close operation. It's exit on close, right? Which means when somebody quits this window, when you click on the red button to quit the window, what happens? It also terminates the JVM. This window is enabled. The font, the foreground, color image, modal exclusion, which means what happens if this window is selected, can other windows be also selected or not? Opacity 1, resizable, true. If we don't want this to be, if we don't want the window to be resizable, we can set this to false. So right now, if you run the application, the window is resizable, right? So the user can resize it. So if we set this to false, and let's see. Where was that? So right now it's false. So let's save this and then run this. And as you can see, I cannot resize it, right? It's the fixed size. And I think for our use case, it's better to make it fixed size, right? And but for now, I'm going to set it to resizable. That's fine. We probably want to increase the if I say increase the in height a little bit. All right. So what do we want? We want to split this into two parts. Split the JPanel content pane into two parts. One is has a grid layout. The other one has a text field area, right? So I am going to select some layouts. I'm going to select a grid bag layout, right? And then in the layout, I'm going to select a JPanel, and I guess let's go back to our PowerPoint to see. So we want to have 1, 2, 3, 4 rows here, and then one big row here, right? So going back to Eclipse, I'm going to select a JLabel 1, all right, and then a JLabel 2, another JLabel 3, another one 4, and then a JText field, and then here, all right, another JText field here, another JText field here. No, we don't want this. Let's undo this. JText field here, and another JText field here. And then I want to have a J button right after the first one. So I click here. And then I want to have a J checkbox after the second. And then eventually I want to have a J button at the end, right here for install. And eventually I want to have a big area here. So I'm going to create a JPanel and add it here. And right now it's going to occupy one row, I believe I can make it occupy the entire columns. And let's see, okay, something like that. And I want to give it a border, so a titled border, and we're going to set the title to log, and title color, let's set it to blue, something like this. And foreground, and then background. So let's have a quick look at this. So this looks relatively nice, and obviously we have to work on some stuff, but right now this is the general layout that we have. We have this log, and as you can see, the code gets very long. That's why we have these automated tools to generate the code for us. Otherwise it's going to take quite some time to add these components. And the most difficult part is always to get the layout right? Which parts grow automatically, which parts we don't want to grow, and that's always easier to use to automatically control using a graphical interface, right? So I hope you enjoyed this lecture. In the next lecture, we continue improving this and finishing this. I hope you enjoyed this one. Please stay tuned, and I'll see you in the next one. Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue on implementing the Maven jar installer GUI in Java using the Java Swing API. And we said that the goal is here for the user to provide a path to the jar file, group ID, artifact ID, and version of the jar file. And then when the user hits the install button, we invoke the Maven command line tool, and then it's going to install it into our local Maven repository. So let's head back to Eclipse. So we added these labels, right? So and then we have these text fields, and then these buttons, right? Now obviously this button, we want to the text, instead of new button, we're going to change it to install, for example, and it's going to automatically also change it in the code. And then so the labels also, we can change the text. So the first one is the jar file, all right, and the second one is the group ID, and then artifact ID, and then the last one is the version, right? Okay, so alignment, we want to left align this, so vertical alignment, horizontal alignment. So let's run this first to see what we're doing. So we have this jar file, group ID, artifact ID, and version, and we said that basically what happens is that the labels, or J label, is for printing or adding textual information to the GUI. Okay. Now what we want now is to this looks okay, but maybe it's better to left align these. So horizontal alignment, we're going to set this to left, for example. Let's see if this changes anything. Let's run. So this didn't really change that much. Left vertical alignment, we're going to top, center, bottom. So the center is fine. And then horizontal alignment, I think the left. So let's see, horizontal alignment, left. Okay, right click here, horizontal alignment, left. And here, artifact ID, horizontal alignment, left. And then version, also the horizontal alignment, left. Okay, now if we save and run, now this looks kind of better, right? So we probably want to add a little bit of offset or padding before this, right? So we can do that, or for now I'm going to leave it. So the other thing is that we're going to change the name of the variable. So we said Eclipse window builder options or configuration to create fields or global variables in our class instead of local variables. So the convention that I always follow is that after I choose the name, so for example jar file, I add the type of the swing component. This is a text, the J label, right? So J file, jar file label, for example. This way the code is also relatively readable, so I know that see the Eclipse automatically changes, also rename the variables. So the jar file label, it's very easy to tell me that okay, this is a J label and it's for the jar file, right? So the other one, group ID, although we're not really going to use any of these labels, right? So it doesn't really matter if we have defined any variable for them. This is the group ID label, artifact ID. So maybe let me zoom in. So this is artifact ID label. So I always append the type of the swing component to the name of the variable that I choose, so that when I look at the code, I know exactly what type it is, right? So variable, this one is version label. All right. And when we save, it's automatically going to refresh everything and the version label. So let's run this and it works fine. All right, jar. All right. Obviously there are ways to configure this. For example, if the user inputs the value, we can change the color of this or make the font bold. So if you look at here, you can set the style, change it. Everything is configurable. All these properties are configurable in Java, right, in the code. So text fields, so let's see. So the log file, so these are the labels, and now the text fields. And again, the first one I'm going to say jar file text field, right? So this means this corresponds to the jar label. And then the other one, group ID text field. And then this one is artifact ID text field. So I have an artifact ID label, which means it's this label. This one is artifact ID text field. And finally, version text field. All right. And then this install button, obviously we have install button, right? And then what I want to do right now, if you look at the button, it's not filling the entire grid, right? So so what I want to do is let's see, horizontal alignment, we're going to select fill, and the button is now going to fill the entire grid, right, the entire one. And if I run this, you see it's filling the entire block, right? Obviously we have the quit, and then so there is a button here. I'm going to select set the name browse button. And then horizontal alignment, I'm going to also set it to fill. And this one, we want this to check the user selects if there is a POM file inside the jar or not. So has POM checkbox. And horizontal alignment, so then text is also has POM. And horizontal alignment, we can also set it to fill. It's not going to change that much. So has POM, new button, install. So we forgot here to also change the text. So browse. Okay. So now the browse is there. Everything looks good. Let's run this. So jar, okay, version, and then we have the browse, has POM, and install. Maybe also let's capitalize this install. All right. Now, what about this log? So we set this as a panel, but I'm going to remove these. We want to have a JText area to basically print the output of the Maven when we run the command line. So I'm going to expand it. And then what I'm going to do, I'm going to wrap it, so surround with a JPanel that has a border. And I'm going to set the title. So there is a border here, which is titled border. And I'm going to set the color of the title and set the title to log. Okay. Yeah. And we can also set the entire background of the panel to white. So we can select white, for example, here. And then let's save and run again. And as you can see, now we have a nice white background. Now, right now, the labels are expanding, so what we can do here is to set these to basically let's see. So I don't want this to grow, and right now the middle one is growing, so let's run this and check it. Yeah, this looks okay. Obviously, we said that the best approach at the end is to fix the size, because we don't want the user to there's no point in resizing the window, right? But right now it can work, right? All right, so the buttons are labeled. So let's see, all the buttons are now so we have a J menu. It doesn't so we can also rename this. So this is file menu, and then this is quit menu item, for example. And I believe we had let's see, so we have this quit menu item, and we're using it in a lambda expression. Everything looks okay. And I'm going to add another J menu, and I'm going to call it log. So set the text to log. Let's see, let's go back to our PowerPoint. So yes, log. So, and then so let's log menu, and then I'm going to add a J menu item, and I'm going to call it clear, or we don't need the 3 dots. So clear the log, and then clear log menu item. Okay, so this is just for clearing the log. And when this happens, what we want to clear the text in the text field area, right? So right now, if I run this, now obviously we don't want the user to be able to type. So right now it's editable, but then I want when the user clicks on the clear, I want to clear up this JText field area. So the way we do it, you select the text area, and then let's also say log text area. That's the name of the variable, and I give it an action listener. So basically we give an action listener to this clear menu item. So add event handler action performed, and it's going to set it to let's see, clear log menu item action performed, and we're going to get this JText field, right, which is the log text area. So log text area, and does it have a clear? No. Instead we set the set text to an empty string, right? So just empty string, and this is going to clear the log. So if there is some text here, output of a Maven run, then we can clear it, right? And click on the log. Okay, so again, I want you to fully understand this concept of actions. And what happens here is that when you click something, an action is going to be performed, and it's based on the action interface. So action performed, and right now, if we look at where this action listener is registered, so we have a where is that log text field, log text area, or basically clear log menu item. It's going to be here, and again, it's based on an anonymous class. We can convert this to a lambda expression. Okay, and then so this is the event for clearing the log. So this one is so for the install, let's implement the install first. What do we want to do when the install is pressed? So we want to run the Maven command. So how do we do that? In order, and Maven is a command line tool, right? So I basically have to be able to tell the operating system run the mvn command and install plugin and install file, for example, something like that, right? So that's the command. So what we're going to do is, obviously I'm going to add an action listener. So action performed, this is an event for this button, right? Install button, action performed. And what are we going to do? How are we going to, so basically the goal is to run a command line, basically command, right? Command line command, or command line application, which is Maven, right? And we already saw what the command is. In order to install a jar file, we can use the Maven install plugin, so something like this. And so I'm going to go back and let's copy this, keep this as a comment here. So we're going to obviously have a string command which start with mvn, right? And then what are we going to do? So let's see, mvn install file, this is the command, and after that we're going to have a -d file. So let's say f1, a string f1 is -d file equals %s, and we can use the string.format, and so the -d file equals %s. And what is this %s? It comes from the jar file. So jar file text field, right? And then get text. Yeah, that's why I always append the type of the swing component to the name. That's why if I want to address this text field and get the text, I already know what the name is going to be, right? It's a jar file, but it's the text field, not the label. So I always recommend that when you're using swing, append, when you choose a name for your variable, jar file for example, append the type of component that you're addressing. So this is the file. So a string f2, again a string.format, and -d group id equals and %s, right? And what is this group id? Again, we're going to say group id text field, not the label, and then get text. And then a string f3 is a string.format -d artifact id equals %s, and then artifact id text field get text. Okay, and then a string f4 is a string.format, and then -d version equals %s, and then we're going to say basically let's not select any of these components, and then version text field dot get text, right? And once we do that, we say that a string, maybe instead of defining the command at the top, we can define it at the bottom. Let's remove that one. Install Maven install plugin, install file goal, %s, and then let's use a string.format, a string.format. Okay, and then so the first one is F1, F2, F3, and F4, right? So Maven install -d file -d group ID, artifact ID, and version. For now, let's just print it to the log. So print the command to the log. So we say that log text area dot set text, or append text add, or maybe append. So if you already have some text and you want to append it, you just say the append text, which is the command. All right. So what happens when we press the install? It reads the jar file text field, and then group ID text field, artifact ID, and version, and prints it to the console. So let's see. So some jar file, and then group ID com.learn Java, artifact ID jar file -jar_file1 version 1.0 a snapshot, and let's click there. And as you can see, we have the MVN install, and then -d some jar file, right? And then group ID. Now on the terminal, we know that if we cannot have an empty space, right? So we have to escape them or put these in single quote or double quote, right? So what I'm going to do, I'm going to put these in single quote. Probably works. We'll see. Group ID. So I'm going to set the file in single quotes. So some file, group ID, whatever, artifact ID, jar1, and version 1.0. Let's see. So some file in quotes, and then group ID, and then artifact ID, and then version. Okay. And then we can clear the log, install again, and then file quit. So this all is coming together very nicely. And then the last question is, how do we basically execute this command in Java? And this is the topic of the next lecture. So please stay tuned, and I'll see you in the next one. Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on how to build a simple graphical interface to install jar files using to our local Maven repository. And we said that, so basically so far we've looked at how to ask Maven to manually install a jar file, and then we created this graphical interface. And then we said that the user specifies the path to the jar file, group ID, artifact ID, and version, and hits the install button, and it's going to show up the log, which is the output of the Maven. And then the next question was, how do we execute a command line, basically command inside Java? And the answer is, we use the runtime class. So the runtime class is an abstraction of the runtime of the operating system. And if you look at the structure of the runtime, you see that it's a singleton design pattern. So it has a private static final field, which is the current runtime, which is an instance of the runtime, and it's static, so it gets initialized as soon as you call a method or anything on the runtime, right? When the JVM starts, it initializes this. And as you see, the construct is private for this class. And the convention with singleton is that you create an instance, and you usually have a public static method called getRuntime or getInstance, which returns this current instance. And depending on the developer, this could be a lazy initialization or eager initialization. Lazy initialization for a singleton means if somebody doesn't call, if this method getInstance or getRuntime never gets called, then the instance is never initialized. But eager initialization is that this instance gets initialized at the very first time this class is loaded, right? And then you see that we have these exec methods, right? Exec. We have 6 different variants of the exec methods, right? And these are public methods. These are not static, which means we have to get call the get runtime method first to get a reference to the runtime class. And then we have these 6 exec methods, right? And you see one of them takes a string command. The other one takes a string array, command array. And the other one takes a string command, a string array of the environment variables, right? And then the other one takes a string array of environment variables. The other one takes a string as the command, a string array environment variables, and the file, which is directory. And this is very important, and we will look at it. So this directory means the working directory, because when you run the terminal and execute a command is always getting executed in a working directory, right? So if you use the pwd, which is the print working directory, it shows you what is the current directory that the command is getting executed in, right? So the concept of current working directory is something that when you need to execute a command in the operating system, you have to always know what the directory is, right? And then the last one, exec, takes a string array of the command array, a string array of the environment variables, and the working directory, right? So if you want to change the working directory or execute the commands in a different directory, you specify this file. If you set it to null, or if you use the first version, basically it automatically sets the working directory, this file, to null. And you see that in the documentation of the first command, exec a string command, which is typically what we use, executes the specified string command in a separate process. And know that all these executions return a process. And again, a process is something that is executed or scheduled for execution by the operating system. And it's basically the concept of process is something that it's an execution that happens separate from your current Java execution, right? This is a convenience method. An invocation of the form exec command behaves exactly the same way as invocation of the exec. This one, a string command, environment variables, you set it to null, and then the working directory, you set it to null, right? So let's look at how to specify the working directory for JVM inside Java code. So first of all, you get a handle or a reference to the current runtime. Again, it's a singleton, so you call the static get runtime singleton class, which means it's one runtime per JVM. And then you construct your command. So a string, let's say I want to install my jar using Maven. So my command is Maven plus this arguments -d file equals something, -d group ID equals something, -d artifact ID, etc. version. And then I say runtime.execute command. I don't set any environment variable, and then I can set also the working directory. Basically, this means where to execute this command, which folder or which directory. And you, again, Java's abstraction of the file system is a file. So a file is an abstract of any file or directory. So ambient directory is new file, some directory. And then this command gets executed inside this working directory. And then the return type is a process. And process is an abstraction of the actual process running by the operating system, which means now you can inquire that process, whether it's completed, what's the output of the process, if the result of this execution prints something to the terminal. And if we want to print the output of the execution, we get a handle to this process P, and I create a scanner and feed it the p.get input stream. So a process has an input stream, and this means from the operating system to the JVM, right? That's why it's an input stream. This is an output of the process, but we want to feed it to the JVM, right? So that's why an input stream. Input stream means something, some stream from outside to the as an input to the JVM, right? And then we get a scanner, and a scanner can read line by line, word by word, etc. So it implements iterator, so it has next or has next line. So I want to read all the outputs of the execution of this command. And obviously it throws exception, so we can print a stack trace. So let's head to Eclipse and try to implement this. So back to Eclipse. So far we have, let's look at the GUI. So far we have created this GUI, right? And we have this menu bar, etc. So if I run this, you see that we can run the GUI. We have this menu bar, and then we said that if we specify some jar here and then group ID com dot something learn Java, and then artifact ID, let's say jar installer, and then version 1.0, and if we hit the install button, it's going to handle this event action performed using this stub or method install button action performed. And right now we're just creating this command and we're printing it to the console, right? Printing it here, and if I hit it again, it's going to add the new command. So what we can do, and we said that this quit also quits the application and terminates the JVM. So when we print it to the console, I'm going to also append a \n. So let's run this one more time. So something, and here let's do some random stuff, version 1.0 install. If I hit it again, now it prints it on the next line. Okay, so this looks good. And then what we want to do now, we want to basically execute the command. Now we want to execute the command. So how do we do this? As we said, we get the runtime. So runtime from Java lang get runtime, and this returns a reference to the current runtime. Let's create a okay, so let's make a variable out of this. So runtime, okay. And then what happens here? So we're going to say runtime.exec, and we're going to execute it in the current directory, and then the command is already there. So all right, and this is going to basically throw exceptions. So we're going to catch the exception, surround with try catch, right? And then print the stack trace, and then once we get the runtime, once we execute it, this is going to return a process. So I'm going to get a handle to this process. Maybe we just create a variable out of it. Let's call it P, and I'm going to create a scanner, and then feed the input stream. So one of the versions of the scanner takes an input stream, p.get input stream. As you see, it has the get error stream, get input stream, which means from the operating system to the JVM, and get output stream, which means from the JVM to the operating system. Right now we're going to get the input stream. Let's make a variable out of this, and we call it a scanner. And then what I'm going to do, I'm going to iterate. I want to look at the output of this process. So I iterate on the scanner while it has next line. I'm going to say that sysout scanner dot next line, and I don't want to actually print it on the console. I want to print it in the log, right? And our log text area, so log text area dot append. I'm not going to say set text because it clears up. Append doesn't clear up, it just appends the text. Append is a scanner next line, and then but a scanner, when it returns the next line, it removes the \n or line feed. So I'm going to also say \n. All right, so we're going to execute, and then we're going to basically print the result to the console. So let's run this. So obviously if I just try to install some random thing, Maven is going to fail, but we can look at the output, what Maven generates. So right now the command is getting executed, and these are the outputs of the Maven, right? So this is the command that we are executing, and the Maven says scanning for projects, and then building Maven jar. So it all right, so it says that this some jar doesn't exist. and then build failure, fail to execute, gold, Apache, Maven plugins, Maven install file. So it failed because obviously these are not correct. To see the full stack trace CDs for more information. So right now we are successfully executing this Maven command, and we are also feeding the output of this command from the operating system to the JVM, and we can print it. Now, if I hit install again, it's going to basically do the same thing. As you can see, sometimes maybe it's better to put some line. So we can also clear, and then we can execute. And now what we are going to do is, what I'm going to do, look at this print the command to the log. What we're going to do is say that log text area get text, and then what I'm going to say that if when we get the text, the length is greater than 0, which means there is some string already in the command. And what we want to do, we want to then say that log text area append, and what I'm going to do, I'm going to get this string dash dot repeat command dot length. Okay, and maybe so I'm repeating this, and maybe plus \n or system line separator, and maybe it's good to, let's try equal. So we're going to repeat it to the length of the command. So let's run this. So some jar, random stuff, artifact random version 1.0, and then install, and it's going to fail. So let's run this one more time, and as you can see, now we have this double line, which is nice, right? So it executes, and what you see here is that the problem right now is that we cannot scroll down, right? So that's a problem. That's because right now we have this panel text area, and it's wrapped inside the panel, right? But what we want to do is probably surround it with a J scroll pane. Let's see if this fixes the problem of scrolling. Let's save and run this. So if I try to say some jar, and then some random group ID, and then artifact ID, some version, and install this, let's see what happens. Okay, so this is one output. Let's see, look at the second output, and now we can scroll down, right? So if we want to enable scrolling in our text area, we have to surround our JText area with a J scroll pane so that it can automatically help us scroll down, right? That's one thing. So this is how we're going to execute the command. In the next lecture, we're going to look at how to enable this basically browse button using a J file chooser, right? I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one. Hello and welcome to another tutorial. In this tutorial, I'm going to continue our discussion on building a graphical interface for installing jar files into our local Maven repository. So far, we have successfully built this GUI, right? And what I'm going to do first is, you see the dimensions are a little bit off, so we can increase the dimensions. So if we just go here and select our J frame and try to increase the size, it's going to manually increase the size for us. And you see set bounds, it's now 807, 648. So if we run this, the size is going to be larger, which is let's see, so in the content pane, in the J frame, or we can manually, so set bounds, resize this component. So if we run these, right now it works, right? So we have a bigger size and we can manually adjust it. So the user has this option to manually adjust it. But as you can see, right now the window doesn't have, or the JFrame doesn't have a minimum dimensions. It's always good to also set a minimum dimension. So what I'm going to do here is that so we have the foreground, and then so it's at the moment it's resizable. When we set the bounds, we're going to say set minimum size. So set minimum size, it takes a dimension, so new dimension, and then int width, int height. So I think it's always good idea to let's say 600 and 400. That's our minimum size. So if we save and run, so this dimension is the 800 and 600. This is the set bounds. And if we try to resize, now you see that it's basically, it doesn't allow you to go below this minimum size, which is very good because most of the time we don't want the user to be able to scale, reduce the size to 0, right? Maybe this is a better size, so I'm going to increase the height, minimum height. So something like this, and then if we try to resize, yeah, we cannot resize lower than this, which is relatively nice, right? So if we just hit the install, it's going to obviously fail, and then we can resize, and we have this JS scroll pane, which we wrapped our text area into a scroll pane so that we can scroll nicely, right? Which is very nice. All right. So there are a few things that I want to discuss. The first of all, we wrapped this -d file into single quotes. Maybe it's better to remove this. And then the other one, if we go back and look at the install command, we saw that there was a packaging. So we have to also tell Maven what kind of packaging we're going to use, right? There is no default value for this packaging, so we have to tell Maven. So we're going to add this argument also. So let me just increase the size. So a string f5 is basically -d, packaging is jar. All right. And then I'm going to add one more string formatting here, and f5. So -d file, group ID, artifact ID, version, and packaging. So we specify for Maven what packaging we're using, which is supposed to be jar, right? And then when we launch this command, Maven always tries to find the jar file in the working directory that it's launched from. So if we look at the so we said that when you execute a command in terminal, for example, mvn --- version, so mvn always look at the current working directory and tries to find the jar file there, right? So what I'm going to do, first of all, we can test this now. So I'm going to try to put a jar file. So when we launch our GUI application right now from within Eclipse, it's going to run it. If you look at the working directory, it's a project file, right? So the working directory right now is this folder, which is where our POM file is. So I have another Maven project, which I'm going to open it, and it already has a jar file. So I'm going to copy and paste it in my working directory here. And now let's close this. Close this project, and I'm going to use our GUI to install this jar into my local Maven repository. So I'm going to launch this, and then the jar file, let's copy the name, and then group ID, let's just say com.learn Java, artifact ID, movie timeline, and then version. And then version, let's just say 2.1, something basically random, right? So let's hit install. Let's see what happens, and build success, which means it was successfully able to install this jar file. And you see this is a relative path, not the absolute path, right? Into my into my as a jar packaging into my Maven repository, right? Installing this into my .m2, and as you can see, it also, because we haven't enabled this option, has POM. So Maven assumes that there is no POM file, so you see it uses the temporary folder of my operating system to generate a POM file, and then it also copies it into my M2 repository where it installed this jar file, right? So now this application works, and we can also test it. So what I'm going to do is, if I go to my POM file of this project, because right now this jar file is installed, so I should be able to add it as a dependency to my Maven project. So let's see. What's the name? com.learnjava, that's the group ID. com.learnjava. Artifact ID is movie-timeline, and version 2.1. And let's hit and save. And Maven now, it should be able to basically grab it from my dependencies. Let's see, why is this complaining? Missing artifact jar 2.1 com.learnjava dependence. So let's update the Maven update project, hit OK, and I guess it's still complaining. Why is that? Okay, so there is a yeah, so we have to add an E here. I guess it was a misspelling, and now Maven was able to grab this jar from my Maven local repository. So I use the GUI to install this random jar into my local Maven repository. Now it's available into all my Maven project. I can quickly pull it to my Maven dependencies and build my project. So that's relatively useful. But now the problem is that one problem that we are facing is that right at the moment, so let's remove this dependency from my project and save. So one problem that we are facing is that if we use the absolute path, I believe it's going to fail. So let's try that. So let's run the project. So if I use a absolute path, so let's just say something random, and then test random version 1.0. So let's see what happens. It was able to successfully copy it. So it works both with the absolute path and relative path, because we are specifying the packaging, and Maven knows that it has to take this. So you can either use a relative path or an absolute path. Relative path is where the JVM working directory is, or basically where you launch this Maven command. Or if it's an absolute path in a Unix-based operating system like macOS or Linux, they start with /. In Windows, it starts with the name of the drive, C:\/ for example. And Maven already knows how to differentiate between absolute path and relative path. And again, we can check that this installation was successful. What I can do is I just go back to my POM file, dependencies, and com.test, and then what is the artifact ID? test-random, and what is the version? 1.0, and hit OK, save, and Maven now goes to my local Maven repository and grabs this jar file, right? So this is a very nice thing to have, and it's very easy to develop it in using Java Swing, right? All right, so I hope you enjoyed this lecture, and please stay tuned, and I'll see you in the next one. Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our project on creating a simple graphical user interface to manually install jar files into our local Maven repository. And we also saw that how to run a terminal command, which is the Maven tool. and specify the file, group ID, artifact ID, version, and the packaging. And eventually we ended up with a nice GUI which can in fact install jars, right? But then we can add more interesting features that the Java Swing allows us to do. That one is drag and drop. You see, so we haven't implemented this browse functionality yet, but a very simple feature that we can enable is being able to drag and drop a jar file. Click on it and drag it into the jar file text field, and it automatically copies the path, the full path to this jar file, right? So that's actually a little bit easier than clicking on the browse and navigating to where that file is, right? So how do we do that? It's actually very easy. We're going to get this, so we have to handle some sort of event, which is a drop event on this J component, Java Swing component, which is a text field, right? J text field. So we get a reference to this text field and call the set drop target, right? So basically what happens when this text field is the target of a drop. And then this accepts, and this method accepts a drop target object. So we can create an anonymous class with the drop target. And then we're going to override the drop method. And the drop method basically implements what happens when a drop is accepted. Obviously the first thing, and it has a drop target drop event, right? So basically we know that Java Swing is based on the event mechanism. So when a drop happens, this drop method is passed a drop event, and then the very first thing that we have to do, we have to allow dropping to happen. And in order to do that, we accept the drop, and then we have to tell it what kind of action is going to be accepted when the drop is accepted by this text field. And we're going to say we're going to do a copy, right? So we're going to do a copy, and then so after we accept in the drop event, then we have to ask the event to give us the transferable. What is actually being transferred? Is it a file? Is it all right? And then this transferable and then this returns a transfer handler. And then we can ask that to give us the transfer data, get transfer data. And then you have to tell what kind of flavor it is, or what kind of data. Is it an image? Is it a string? Here we're going to say it's a file list flavor, and this returns an object which we cast it to a list of files, for example. Now in this case we're going to assume that there's only one file is dragged, but in general a user can actually select multiple files and drag them in a J component, right, in a Swing component. So that's why this actually returns a list, a file list, right? But then here the assumption here is that we only have one file, so we can accept only the first one or the last one. That's depends on the developer, which is us, right? So let's head to Eclipse. Now this is our GUI. So if I run this, we're going to have our nice GUI which we can implement, and then we can clear the log file, and then we can quit the application. So what I'm going to do right now, so I'm going to select the top level, let's collapse this JFrame, and in the JFrame what I'm going to choose is basically, let's so if you look at the properties of the JFrame, you see we have this always on top, which maybe it's a good feature to have. What this means is that if you run the application and then click somewhere else, this window doesn't lose focus, right? So it's always on top, which at the moment it's a good thing to have for now. So let's keep it as having a always on top feature, and then so it calls the set always on type method in the JFrame, and it sets the boolean flag to true. And now what I'm going to do, I'm going to select this text field, and I'm going to click on this to go to the definition. So what are we going to do with this J text field? We're going to say that so at the moment, so previously we had this jar file. So if I run my GUI and then click on this and drag it into basically my text field, nothing happens, right? So what I can do here now is basically select my J text field, jar file text field. I'm going to say jar file text field dot set drop target, right? And then this requires a drop target object. We're going to create an anonymous class. So new drop target, and then we're going to override something. So basically in the drop target, we're going to right click and then go to source, override implement methods, and in the drop target we have this drop method, right, which accepts a drop target drop event. So we want to handle the event, so we're going to select this. And then now what happens when we have, so let's rename this to event or EVT or event. And then obviously the first thing is we're not going to call the super drop, right? So what we're going to do is that we're going to first say event, basically, let's see, so event dot accept drop, and then the drop is going to be action copy, right? So it's a basically drop event, I believe, something like that, drop target event dot, or we can call the drag and drop. So DND constants, these are the constants that are defined for the drag and drop events dot action copy. So we want to do a copy, so copy, and then eventually we want to get the path of that file, right? So this copies the file or the description of the file to the clipboard, and then we're going to say that event dot get transferable. So get drop action, get drop target context, get transferable, get transferable. This returns a transferable, and then get transferred data. And what is our data flavor? Java file list flavor, right? So this returns an object. So, and then we're going to say that we're going to cast it to a list of from Java, a list of file from Java IO, right? So we're going to cast it, and then so list of files, it's going to basically do this, and unhandled exceptions, we can catch the exceptions, right? Try catch, and let's just print the stack trace. And there is a type safety here. We're doing an unsafe casting, so let's just suppress the warning, and then this gives us a list of file, and we can get the iterate through this, and for example use the first file, right? Let's say we're going to use the first file. So basically we can say for file in files, or use the last one, that's fine. So use the last file. It's up to you how you want to handle, because in a text field obviously there's only the description of one file. If it was the, for example, text area, we could have multiple we could drag and drop multiple files and get all. For now I'm just going to iterate through them, and then say that jar text field set text, and then a file get absolute path, right? So this iterates through them, and eventually if we drop multiple files, it iterates through them and just gets the last one, right? So let's run the GUI to see if this works. So let's run this, and now let's see if I drag this and drop it here. You see now it gets the full path, right? And let's say I drag and drop another file, it gets the full path. If I drag and drop two files, it gets the second one, right? So I first selected the jar file and then the POM file. Let's select the POM file first and then the jar file. So POM, jar, select these two, drag them, and it gets the POM file. So I guess it always gets the second one. So jar file here, and then group ID, artifact ID, and then version. So we can also specify this. Let's say test2 or org.test2 artifact ID test2 artifact, and then version 2.0, and then install. And this is going to execute this Maven command, and then install it in the in my Maven repository, install this jar file, and then it also creates a POM file in a temporary folder and then transfer it to the where it installed this jar file, right? And we have this log that clears things up. And then if I go to my POM file here, go to the dependencies and try to add this we just installed in our local repository org.test2, and then test2-artifact, and then version 2.0, and then we're going to hit OK and save, and it's going to go and grab it. And as you can see, my jar file is here, right? So that's how we can quickly basically install a jar file. And I think it's a good idea to have this always on type, so this window never loses focus and it never goes behind any other window, right? And then now we can easily install a jar file, and it creates a POM file, and basically we can now quickly use Maven to add a dependency to this jar file, right? So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one. Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our project, which was a graphical user interface in Java Swing to be able to run Maven commands and install a jar file, manually install it in our local Maven repository. And we added a very nice feature, was that you can drag and drop a jar file into the jar file text field, and basically this immediately grabs the full path to that file and puts it here. And then this is more convenient than click on the browse button and using the file browser. But in this lecture, I'm going to finally implement this browse functionality, and then we're pretty much done with this project. So let's head to Eclipse and try to implement file browsing capability. So back in Eclipse, this is our project, Maven Jar Installer, and we are using the WindowBuilder plugin for Eclipse. And I always prefer to arrange the editor and the GUI side by side. And then when you change something, it tries to refresh the code on the left side, right? So right now, if I run this, the state is that we can set the path to the jar file, group ID, artifact ID, version, and hit the install button. We can clear the log screen, we can quit the application, and it prints something to the console. That's good. And then install button, it creates a string command for installing Maven using the install plugin and install file goal. And then we specify the file path, group ID, artifact ID, version, and packaging, which is jar. And then it runs the command using the runtime of the environment operating system, and then gets the process associated with this execution, and then it hooks up the input stream of the process to the JVM. We are using a scanner, and we read all the lines and print them to this log area, right? That's the status. Now right now we want to work with this browse button. So what I'm going to do, I'm going to click on this, and as we said before, when we want something to happen, if we press a button, we go to the event handler, right? And then say action performed. And it's going to add this stub or method, which is browse button. Let me put it here. So browse button action performed. It has an action event. So what do we want to do? First of all, we want to open a file chooser window, right? So that's the step one. And therefore, we're going to say jail file chooser fc new j file chooser, right? And if you look at the constructor, you see it takes a file current directory or a file system or a string for current directory path, etc., right? So I'm going to pass it a file, so a new file from the Java IO, and give it the current working directory dot. All right. So this dot means this is the current working directory, and this is the working directory where the JVM is launched. So here basically dot means current working directory for JVM, right? So usually, so if you package your application as an executable jar and run it, this sets, because this sets the JVM, the working directory of your application on the where the jar file is, because that's where actually you're launching your Java application from. And as I mentioned before, in Eclipse, when you look at your run configuration, and Eclipse launches your Java application by default from the root folder of your project, so workspace and the project folder, that's the default working directory, right? So if I launch my application and open a file chooser, because I'm setting it to dot, which means a relative path current working directory for JVM, it's going to open up a file chooser in this folder, Maven John Instance, right? This is the root folder of my Java project in Eclipse, right? Now obviously you can set an absolute path, for example, other choices typically. So typically the user.home property is the default choice. So if you don't specify anything, so JFileChooser has a constructor that doesn't take any argument. So if you look at the constructor, you see it creates a file, and then when there is null, then it sets basically the home directory, right? So this constructor that doesn't take any arguments. So if you look at the documentation and zoom in, constructs a JFileChooser pointing to the user's default directory. This is the home directory, right? And JVM has a system property called user.home. The default depends on the operating system. It is typically My Documents folder on Windows and the user's home directory on Unix. So if you're using macOS or Linux, this constructor that doesn't take any parameters opens up in user.home. If you're using Windows, it says that it probably opens up in My Documents, right? But here I prefer to set my working directory from where I launched the Java application. That's because if I package as a runnable jar and double click on that jar file to open it, to launch my Java application, I want to open up a file chooser from where the jar file is, right? All right, so, and then we're going to tell it to show, we're going to tell it to tell the file chooser to show a dialog. So what dialog is available? Show dialog, show open dialog. We want to open a file, right? Show open dialog, and the parent is this basically this JFrame, right? We are inheriting from JFrame, and the parent means as long as this file chooser is open, we cannot do anything with the parent class, right? With the parent window, it's not going to allow us to do, right? That's kind of like the modality. So show open dialog, and then after that, so step 2, we're going to, so the user, we show user a open dialog for choosing a file, and user navigates and selects the file and hits OK. So user selects a file and closes the window, right? Closes the file chooser window, and then therefore now a file, we can assume that a file is selected. So in a step 2, we're going to say fc get selected file, and this returns a file, right? So file selected file equals this. Now obviously if the user opens the window or hits the cancel, because this window is going to have a cancel button, then this can return null. So selected file can be null if user cancels, right? So we can say that basically now we can say that if selected file is not equal null, we're going to proceed. Otherwise we're not going to do anything, right? Otherwise we just return. So if the selected file is not null, we know that the user has selected and pressed OK. Is the selected file is null, we know that the user actually cancelled. Didn't even if the user selected some file, if the user selects cancel, this method get selected file returns null, right? All right, so what do we want to do? Let's just do a sysout. Let's see if our code works. Sysout selected file get absolute path. Let's see if this works. So I am going to run the application. So this is our window, and if I hit browse, as you can see now a file chooser is opening, right? And as you can see, it opens from where my application, Java application working directory is. As I mentioned, it's inside my Java project. That's because that's what the JVM set and Eclipse sets for the JVM when it launches a Java application from within Eclipse, right? And I have this jar file. If I hit open, and right now, so as you can see, we are printing out the full path, right, of this jar file. And note that there is a dot here. That's because it gets the absolute path, assuming this working directory. Unfortunately, this might not work with Maven. So what we want to do, this file has another method, get canonical path. So canonical path first checks if that file actually exists, which means this is really a valid file, and after that it removes any dot or anything from it and then returns. But then this can throw exception. That's because it has to check first that if the file actually exists, right? So if I launch this one, and if I hit browse, select the file and hit open, as you can see now we are getting the full path to this jar file, and there is no dot. So that dot has been removed from the path because we are using the canonical path, right? But canonical path first checks if this file physically exists on the disk, right? If it doesn't, then it throws an IO exception. So we can get the path. So what we're going to do next is just say that jar file text let's see, so this text field is called the jar file text field. So jar file text field and set text, and then we're going to get the canonical path, and then we're not handling this exception, we're just printing the stack trace, right? So that's it. That's it for actually implementing a simple functionality for file choosing. So let's run this one more time. So we hit the browse, we select our jar file and open, and now the file is there, right? So one thing here is that, as you can see, the file format is all files. So I can select any other file and it specifies. But obviously, we want to limit the user to only use jar files, to be able to select jar files. And for that, we're going to implement a file filter. So the way this works, you before opening the dialog, before showing the open dialog functionality, we're going to add a filter. So fc set file filter, and then you have to use a file filter class, file filter, and this file filter is an abstract class, I believe. Yeah, so you have to implement two things. One is get description, and the description is what is written in that file format box in the GUI, right, which tells the user what kind of formats are allowed by this filter. And then accept, which returns a boolean. Basically, you give it a file and you tell it whether to accept it or not, allow it or not, by returning a true or false, right? So what we're going to do, we're going to override two things. Get description, we're going to say return jar files, right? And then accept, we're going to just say that, so we're going to get the extension or check if .jar is in the file name, right? Which means this is a jar file. So if f.getName this returns a string and then contains a char sequence. What is the char sequence? .jar, or we can capitalize it, that's also fine. So but usually jars are specified, so we can say lower to lowercase, so we get the name lowercase compared. If this is true, we're going to return true, else we're going to return false. So the default is don't allow any file unless this accept returns true, and on one condition the accept returns true. We're assuming that the extension is .jar or capital jar or any combination, right? So we get the full name including the extension, convert it to lowercase, and check if the .jar exists. If yes, true. So if I run this, hopefully this is going to work. And as you can see, I cannot select a folder or basically another file, right? The only thing that I can select is the jar files, this one, .jar. And you see the description here is file format jar files. That comes from this get description method. And you see also the modality. I cannot interact with the parent window of this window. That's because we for the file chooser we set the parent to to basically the main GUI, right? That's why we cannot really interact with it. So if you set this parent to null, then you can interact with the main window even if the file chooser window is open. So if we select, we get the full path, right? So what other things we can do here? And one thing that you notice here is that if I open this, there is a title here which says open, right? So we can change it by telling the file before showing the dialog. We're going to say fc set title. Let's see, set dialog title, and let's see, select a jar file. Set dialog title, and we're changing it to select the jar file. And now it says select a jar file, right? And then we are filtering the jar files. You can go back and actually cancel that filter, and then you can select everything. And then if you activate the filter, then you can only filter the jar files, right? So this is how it works. And then so we select this jar. Let's say group ID com dot final test, and then artifact ID final test Maven jar dash installer version 1.0, and we hit install, and it's going to go and install it and creates a POM file also based on this group ID, artifact ID, and version. And then now if I go back to my POM file of this project, and I want to check if this file, this artifact, this jar file with these coordinates, Maven coordinates, is accessible to my project. So group ID com dot final test, artifact ID final test hyphen Maven hyphen jar hyphen installer version 1.0, and then okay. As soon as I hit save, Maven goes and grabs this final test hyphen Maven hyphen jar installer 1.0. As you can see, Maven, when installing it, it also basically renames it to the group ID. Basically this is the artifact ID, and then hyphen version .jar. So Maven also when it installs in your local repository, it also renames the file. And you see this jar file is now fully available to my Maven project. So I hope you really enjoyed this project, and look forward to doing more projects. So please stay tuned, and I'll see you in the next one.